Hi everyone, this video is to show you how to do every problem in the Unit 7 review packet. This video should be after, one, you've done the review packet on your own, looking things up and whatnot, but trying each of the problems. Two, checking your answers on the other video, which is just a quick check each of your answers. And so this is for the problems that you had wrong. You can skip ahead to whatever questions you want to look at, and I'm just going to talk you through them. I in no way intend you to sit here and listen to this entire video for every single question. But if you need 2 or 3 or 4 or 5, just skip to those and check them out. And I'm just giving you some how to do the problems. All right. Okay, so the first one, complete the table. You have to identify the cross-section parallel to the base. So here's the bases parallel to this one. In a prism or a cylinder, they're going to be exactly the same. So they're going to be congruent. So this one, if we're parallel to the base, is going to be a triangle. They would actually be congruent and the circle would be. In a pyramid or a cone, it will be the same shape, but they will be similar. So it will be a little bit smaller depending on where it is sliced. If you are going to be perpendicular to the base, so now we're going this way, perpendicular to the base, for anything that's a prism or a cylinder, you're going to end up with a rectangle. So you can kind of see that right there. You've got your rectangular pieces that will come down. So this prism as well will be a rectangle. And then if it is a cone or a pyramid, it will be a triangle. As you can see that there's the triangular sides on those. All right, number 2, if you were rotating this 3, 4, 5 right triangle around this side, the leg that has 4, first off, when we draw these, we're going to do a reflection about the line. So here's my reflection. And then any of the points that are on the outside, any of those vertices, you're going to connect with a circle. So they're going to end up being a circular base. So a triangle will always be a cone, and if it was a rectangular, it would end up being a cylinder. So the question says, determine the solid, so the solid would be a cone, and find the exact volume of the new solid. So the exact volume, it's a cone, so we're going to use the volume formula. Volume equals 1/3 pi r squared h. So the radius we need and the height. So the radius, we're going to look here, that's our circle. So that's why it's really important that you rotate it around the leg that's 4, because that's what they told us to do. So that means that this part is where the circle is. So this base is the radius, which is 3. The height would then be the 4, which it was rotated around, because remember, height and base have to be perpendicular. Now we want exact volume, so that means we are not going to put pi into our calculator. We can do everything else. You can do the 1/3, the 3 squared, which is 9, and the 4 all in your calculator. So 1/3 times 3 is actually, that's a 9. So 1/3 times 9 is 3, and 3 times 4 is 12. So you could also just put that into your calculator. So the answer is 12 pi. All right, number 3. What is the volume of a sphere to the nearest hundredth that has a diameter of 14.2 units? So we have a sphere, so our 3-dimensional ball, right? It has a diameter of 14.2. So that's all the way through at 14.2. And we want the volume. So of course we're going to use the volume formula. And if you're not sure on these volume formulas, where can you find them? Dun, 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 dun. Yes, you should be able to find them in your reference table. So the volume of a cone would be your 4/3 pi, or I'm sorry, it's a sphere, 4/3 pi r cubed. The only one that uses cubed, because the only measurement we have is radius or diameter. So volume equals 4/3 pi r cubed. Now you just have to remember that they gave you the diameter, so the radius is 7.1. So if you got that wrong, this one wrong, that might be part of your reason. And part of it might be the 7.1 to the third. Now, if you do not have a calculator that has anything higher than a squared, it's okay, because a square and a cube just means multiply it by itself that many times. So I'm going to do it the way you may not have a, if you don't have a cubed root on your thing. So we're just going to keep multiplying them. It's to the 3rd power, so we're just going to multiply 7.1 3 times. So we get 357 0.911. Might as well use all three. It's good to use to the fourth. Now we do want this one to the nearest hundredth, which means now when we go to multiply this out, we can put everything in our calculator. If you don't have a fraction, 4/3 would be the same as 4 divided by 3. So you can divide that out before you put in your fraction. You really can do just about everything on your calculator. So I'm just going to do second answer so that I can copy that down. And we get volume equals 1499.2141. And we want to the nearest hundredth. So therefore the volume is 1,499 and 21 hundredths, and that's units cubed. So even though it said units like that instead of like inches or whatever, you can still use that as your units. Number 4, it's our ratios things here, converting back and forth. It wants to know if the ratio of the side lengths of 2 rectangular prisms are 3:5. So we know the sides are 3:5. What is the volume of the larger prism to the nearest tenth if the smaller prism has a volume of 48 centimeters? So we're talking about volume. So we need to go through our 1-dimensional, 2-dimensional, 3-dimensional process here. So we have the size, which is 1-dimensional. We need to get to volume. So first, we can't use 3:5. We have to use 3:5 cubed. Okay, so we cannot just compare a 1-dimensional to a 3-dimensional. It doesn't work that way. So 3 times 3 is 9. 9 times 3 is 27. 5 times 5 is 25. 25 times 5 is 125. So 27 to 125 is 3:5 cubed. You cube both the numerator and the denominator. Now that gives us the ratios of the volume. So now we can use that in a proportion. So this one would automatically be the smaller prism and the larger prism because we're comparing corresponding sides, right? So now we can set up our proportion where we have a ratio of volumes and another ratio of volumes. We know that the smaller prism is 48 centimeters cubed, and we don't know the larger one. So we've found 2 sets of ratios that are equivalent, and now we can set them equal and cross multiply. So 48 times 125, I do not know that one, is 6,000. So we have 27x equals 6,000. And we divide that by 27, and we get 222.22. 22. It's repeating here. So the question is, what's the volume? So the volume to the nearest tenth. So 222 and 2/10 in this unit is centimeters cubed because it's volume. So there's our answer. Okay, what is the volume of the falling prism? Okay, so remember prisms, we want volume. We have the general prism here, which is V equals capital BH, right? Really important that you are talking about capital B. So we don't want to say volume equals base times height. That would be that. We want volume equals capital B, or what we would prefer you say is the area of the base times the height, because that's what capital B means. It's the area of the base. So what we have to first distinguish when we plug this in here is what it actually is the base of this figure, and then how do we find the area of that? So it's a prism, so we can see the rectangular sides, and the rectangular sides connect the 2 parallel and congruent bases. So this is a base, and our other base is on the other side. So in order to find the area of the base, capital B, we need to know what shape it is. It's a triangle. And we're doing the area of the base, so we're going to use the area formula of a triangle. So this is half, and it is the base times the height. You want to ignore the rest of the prism. Ignore it. We're just looking at this triangle here. We need its base and its height. So the base and height have to be perpendicular. The height goes from the vertex perpendicular to the other side, which we can see there, and that becomes the base. So that means our base of our triangle is 8, and our height is 6. Half of 8 is 4, and 4 times 6 is 24. So our area is 24 millimeters squared. That's the area of our base, or capital B. So now we can go back to our volume formula. Capital B is 24, And our height, now you have to think about what figure we're finding the measurements for, okay? This volume is for the prism. This area was for the base, which was the triangle. So we weren't dealing with the rest of the prism. So we need the area of the base. So we just found that here. And we need the height of the prism. So the height connects the two bases. So this side, and then the missing one inside here, okay? Those are the heights of the prism, and so that's 15. So 24 times 15, sorry to disappoint you, I also do not know that off the top of my head, and we get 360. Actually, I probably should have known that one if I thought about it. And so therefore the volume is 360 millimeters cubed because it's volume. All right, next one. What is the methods to proving triangles similar? Well, there are 3 methods to prove triangles similar. One is the most common one, which is angle, angle. That's the one we see the most. It has 2 congruent angles, and therefore the third one is automatically congruent, and that makes the triangle similar because they always add up to 180, and that relationship, the sides would end up being proportional. We could also have side, angle, side, and it's not all congruency, so we have to be careful with this. If we were to use this, it would be the 2 sets of sides are proportional with the connecting angle as being congruent. So the angles would be congruent, and then the corresponding sides would be proportional. And the third is side, side, side. So again, not side, side, side in the congruent form, but the 3 sets of corresponding sides are similar. So all of their ratios would be congruent. Okay, so they would all be proportional. So those are the 3. Most important is angle, angle, and that's why you can't use the angles in congruent angles in the congruent one, because the sides just have to be proportional, not congruent. Now, we spent a lot more time with the 5 methods of congruent triangles because that comes up the most. That's the one that you're going to see more likely for a Regents question than similar. And if you do see similar, it's usually, like I said, angle, angle. So what are the methods of proving congruent triangles? Well, we have side, angle, side. This is 2 sides that are congruent, and then their included angle is congruent. Side, side, side. The 3 corresponding angles are congruent. Or, excuse me, the 3 corresponding sides are congruent. We have angle, angle, side. So 2 angles and then the non-included side. We have angle, side, angle. So 2 angles in the included side. And then we have 1. And this is the special for the donkey theorem. You cannot have angle, side, side. It does not work, except for a right triangle. Okay, so if you have the right angle and then you have a leg and a hypotenuse, it would kind of be like angle, side, side. We don't call it that because it only works for a right triangle. So you have to have the 90-degree angle, you have to have the hypotenuse, and you have to have one of the legs. If you had the right angle and the 2 legs, it would be angle, or side, angle, side. So this one we switched to hypotenuse leg. So it's a special only for those right triangles. Number 8, a container of storage is made up of a cylinder and a hemisphere. The height of the container is 40 inches. The radius of the hemisphere is 8 inches. So that's actually all labeled for you. It says, what is the volume of the container to the nearest cubic inch? So in the hint one, we said you got to find the cylinder, you have to find the sphere, divide the sphere by 2, and then add them together. So let's start with the cylinder. So the cylinder formula is volume equals r pi r squared h. So we have that. So the cylinder is pi r squared h. And then within that, we need the radius. So if we look at our cylinder here, it shares the circle or the base with the hemisphere. So the radius of the hemisphere is also the radius of the cylinder. So 8, what am I doing here? Doesn't matter the order, but, well, my eraser's not working very well. Okay, so we have pi times the radius, which is 8 squared. Now we need the height of the cylinder. So if you had this one wrong, this could be your mistake. The height of the cylinder is not 40. The height of the entire solid is 40. So that means the cylinder plus the hemisphere. So how do we determine that height? They actually drew this in for you, right? This is the height of the hemisphere. It's not labeled, but what is it? It's 8 because it goes from the outside of the circle to the center of the circle, also called the radius. So this is 8, which means this distance right here is 8, which means the cylinder is what's ever left when you do 40 minus 8. So the cylinder's height is 32. 32 plus 8 is 40. So that's the height of our cylinder. Now, when I go to multiply this out, and Miss Griffin's class may do this differently, what my class does is either when we look back to see what the question is, and it's going to be a nearest cubic inch. So you're going to be rounding here, which means ultimately pi is going to go into the calculator. So you can do one of two things. You can either plug everything in and keep pi right now until we get to the end, or we suggest 4 decimal places. So I'm actually going to do both, okay? So we've got 8 squared, which is 64, times 32, which is 2048. So I'm going to do without pi, so 2048 pi. So I'm going to keep it exact. Or we can then multiply by pi and use 4 decimal places. That will keep it pretty exact, pretty close to exact, so that if it was asking you to do exact in the end, or not exact in the end, but if it was asking you this problem on the Regents, this could be a good chance to be as close as possible, okay? Now we're going to talk about the hemisphere. Okay, so volume equals 4/3 pi r cubed. Again, I'm getting that from the formula sheet, right? Sphere is 4/3 pi r cubed. I like to write like divide by 2. You can either put it in parentheses or something because we have the sphere formula. We need a hemisphere, which is half of it. If we don't think about that, if we don't write it up here or write it within there, we may forget and use the whole sphere. So we know the radius already. We talked about that. So the radius is 8, and we're going to end up dividing by 2. So we're going to do the whole thing here. We're going to do 4/3 times 8 to the 3rd, which is not a nice number because of the 4/3. So if you wanted exact at this point, we would change it to a fraction. So pi divided by 2. Or, which we can do, we can take that and divide by 2. So let's get that out. So 10^24/3 pi. Or we can multiply that by pi. Excuse me, not multiply. We can divide that by pi. No, I was right. Multiply by pi. I don't know what I'm thinking. And use 4 decimal places. 172.3303. So we've got our hemisphere, we have our cylinder, and we want the entire thing. So we're going to add those together. So if we add these together, we can either use the exact, or we can use the 4 decimal places. And we should, now I haven't done this ahead, I'm doing this with you, we should get very similar. So I'm going to show you my calculator that these are going to be pretty close. So 2048 pi plus, and I'm just going to use this time as division, 1024 divided by 3, and then multiply that by pi. So there's our first answer. And then if we use 4 decimal places, hopefully I put this all in right. You can see we got the 4, and it goes right to, the only difference would be the 4th one. This would stay at 0, and that is up at a 1. But it's okay because we want the nearest cubic inch, which means whole number. So right now we've got 7506.3120 or 1. But therefore the volume is 7,506 inches cubed. Okay, so we want the nearest whole number when it says something like that. All right, number 9, a cubic box with sides length of S centimeters holds N marbles. The density of the marbles in the box can be determined by this expression. So we need the density equals mass over volume. And this is a cube. And it's telling us that all of the sides are S. It's a cube, so every single one of these sides are congruent or S. That's important, okay? So we need to find the density, so we need the mass over the volume. And it actually tells us that it holds N marbles. So how much it holds, that's its mass. So we already know that the D is N over the volume. So right from there alone, actually, kind of scaringly, you're really down to one choice unless there's something really crazy. But we're going to do this math. So we need the cube, which is a prism, general prism. So capital BH, or area of the base times the height. Now it's a cube, so you can actually use that length times width times height, which is the one volume formula that most people remember. But how we would do it if you do not, we look at the base, which is a parallelogram or a square. So that's its base times its height. So S times S. So the area of the base is S squared. So that goes here. And then the height, which is the side that connects the two bases, is also S. So that's S squared times S, which is 3 S's, so S cubed. So number 4 is our choice. Okay. All right, number 10. A solid sphere has a volume of 288 pi cubic inches. Find the radius of the sphere. So we're back to a sphere. This time we have the volume of it. So we need the volume formula again, which is 4/3 pi r cubed. I'm getting that from my reference table, okay, for a sphere. We know the volume, so when we plug in the number, it goes in for V, for the actual volume. The only thing missing in a volume formula is the radius, which means if you're given the volume, you can easily find the radius, which is what we're looking for, by solving. Now, I say easily because it's only one value, but probably solving it is maybe why you're here looking at this question. So it's a little bit trickier because we have a fraction, we have pi's, and we have r cubed, okay? So the first thing we're going to do, I like to do, is get rid of the pi. You have a pi being multiplied on both sides. And this works for anything. If you have a number or a letter being multiplied on both sides, they divide out evenly. So you can actually just cancel them on both sides. The process is taking one of them and dividing them out. So they will divide out to be 1, which leaves 288 times 1, which is 288, and 4/3 r cubed times 1, which is 4/3 r cubed. So that makes it just a little bit nicer looking, and it gets rid of that. Now we're solving for r cubed, which means we have to move the 4/3 to the other side. And there are multiple ways to do this. You can split the 4/3 and say it's 4 divided by 3. Move the 3 by multiplication, the 4 by division. That's probably not the number one way you guys would do this. You can straight out divide by 4/3. It's being multiplied. So you can divide both sides by 4/3. Or, because it's a fraction, you can multiply by the reciprocal. So you have these two options in how you're going to do that. So I'm just going to put them both up here. Like I said, the first option, more than likely you are not going to do. And if you can do it, you're fine. Because that's something that we don't normally do. So that means you just got a really good grasp on fractions, which is not typical. And that's okay. So you can divide this by 4/3 and divide this by 4/3. And you might be like, yeah, that's what I did, but I still didn't get the answer. So in your calculator at home, you have a couple of things. If you take your cell phone, I'm using my cell phone, but if you take your calculator and rotate your screen so it goes on its side, it's very possible that you'll end up with a fraction button. If not, your 4/3 have to go in parentheses if you can't put them in a fraction. Or change it to a decimal first. So 4 divided by 3 would be, oops, my calculator went off because my batteries are low. So 4 divided by 3, I'm not going to, say that maybe some teachers are very prepared with their calculators and I'm not, because my batteries are going to not last. 1.33333. So if you use 4 decimal places and take your 288 and divide by 1.3333, you get that. If I do it exactly, 288 divided by, I'm just going to use parentheses around my fraction. because that's more than likely how some of you would do. You could put it in that way, and you're going to see it comes out exactly as 2/3. So 2/3 versus 0.0054 are going to work out pretty closely for us. Okay, so it is 216. The other option, which you may be, is you can multiply by the reciprocal. So if you multiply the 288 by 3/4, another way to get rid of, not worry about the fractions with something like multiplication where order doesn't matter, you can do 3 divided by 4 first and then multiply by the 288. So you get the exact 216 as well. You know what? I'm going to change this to, let's say you got the decimal and you didn't know it was exact. 0.0054. Okay. Now where it might be a little tricky for you. If you are just using your regular calculator, your regular cell phone, not turned, you probably don't have a way to do exponents. You may have like y to the x power, and that's probably something you can do, but I don't want to lead you astray in finding out which way to put it in. However, once you get the answer here, you can play around with your calculator and then you'll know how to put it in, which way will give you the correct answer. Okay. So on here, we have cubed. So we need to undo the cubed. When we have squared, to undo a square, we use the square root. It's the same for cubed. So if something is cubed, we use the cubed root. So how we show that, instead of just that, because that means square root, we put a little 3 in there, which technically the square root has a little 2 there, but we don't have to use it because it's the most common. So we're going to use the cubed root of this. We need to undo the cubed root. So in our calculator, we would find that under math, down here at number 4, that's actually the cubed root. And now I can put in the 216 or the 216, which is going to be exact. Or I can add in there the 0.0054, and you will see that it comes out to be just a little bit. But see how it's 6.00005? Even if we were going to round that to the nearest whole number, tenth, hundredths, thousandths, they're all going to be just 6. If you go all the way out to the 10,000ths, it's going to go up to a 0.0001, which probably should be a good indicator to you that the exact answer is 6. Okay, so R equals 6.0001 or R equals 6, but therefore the volume, or not the volume, excuse me, the radius is 6. And we do have a unit. If we look up here, it says that the volume was cubic inches. So then one-dimensional would just be inches. If you can't do the cubed root, something from algebra, you can change it to exponential, okay? The exponent is a fraction. So if you were taking the square root, it would be, because it's 2, you would do 1/2. If it's cubed root, we do 1/3. So we can go 1 divided by 3 as the exponent, and that will also give you 6. So that's going back to your algebra teaching and whatnot. Now, if you're taking the test and you're not sure how to do some of this stuff, you can put into the if you have a computer access to Chrome, you could put in there like how to do the cubed root of something, and you'll probably get a calculator that will work for you on Chrome as well. Okay. I have not discussed this with Miss Griffin, but I think that most of us would be pretty comfortable if you wrote down the answer, like the answer would be the cubed root of 216. Whether you can do that or not, I don't have a calculator that can do that, so that's what my answer would be. I would be very comfortable with that. I have a feeling Miss Griffin would be as well, if you could write out what it was, because who cares if you put the number in the calculator and figure it out. Okay. All right, number 11 was this is a really cool example. I like this, and we've actually seen something similar to this a few times on the Regents exams. So you're taking a circle, right? You're breaking it down into sectors. And so all a sector is like a triangle, but the end is curved, okay? And we're going to talk about that in one of the coming units. The sectors are then arranged as shown in the diagram. So you're just looking at this and seeing, where does this come from? You can work this way and go back to the circle, or you can use the circle and work backwards. So this X right here is this side, not, completely straight, but it gets pretty darn straight. But each of those are some curves. That would be the same as here. The same as here. And so that means even connected, it would be the same as this here. Which, if we look at the original circle, that measurement that's on the outside, the whole thing is the circumference, which is pi d. But we have half of it, so divided by 2. And just like that, we have a formula. C, or x, I mean, is half of the circumference. So if we look back here, it says that it's a circle with a radius of 5. So we can also use 2 pi r. Forgot that is also on your sheet. So with circumference for a circle, both of your formulas are there based on what you have. This one is using the radius, so we can actually use the bottom one to figure it out. So we know that x is equal to 2 pi r divided by 2. The radius is 5. So x equals 2 pi times 5 divided by 2. So it would be 10 pi over 2. And you can just divide out those numbers. So 5 pi. So the segments are arranged as shown in the diagram to the nearest integer. Find the value of x. So we actually are going to multiply 5 pi. And we get 15. Let's do this on here first. So x is 15.7079. Okay, so if I go to 4 decimal places to the nearest 10,000s, I'm rounding 9. 6 rounds it up. So what I actually am looking at is 79, and I'm rounding that up to 80. So it's going to be 70, 80. That's how you round up a 9. You actually look to the two numbers, what is that, and round them up, because the 9's moving that up to a 8 and moving it up from 79 to 80. So what's the nearest integer? So there's the whole number, so x is 16. And no units are given. Parallel lines in the diagram, angle 1. So we know that 1 is 3x plus 8. 2 is 6x minus 10, and we're actually looking for 3, which they didn't give us some information on yet. However, if we look at that, we know in parallel lines are either, or all of the angles in parallel lines are either congruent or supplementary. Number 3 is congruent to which one? I shouldn't say that. It's not. It's not congruent to any of them. 3 would be the same as this angle up here. This would be its corresponding angle. This would be its alternate interior, and then its vertical angle. So 3 is actually congruent to any of those 4, which means it's not congruent to 1 or 2. However, looking up here, it's supplementary with them. So if you can find 1 or 2, we can find angle 3 because it's going to be supplementary to 1 and 2. So what's the relationship between 1 and 2? Well, they're vertical angles, and vertical angles are congruent. So